Hey, quick question here from a friend Ariel regarding how to convert numbers from binary to decimal. Something that's pretty important in computer science, though I'll admit I rarely have to do it by hand. Something I learned back in high school, and I think it's worth knowing. So this is going to be the breakdown. We're going to talk about binary to decimal. We're going to talk about decimal to binary. Let's start with a number I chose, a decimal number, 142. I think it's really important to just take for a moment. We kind of take it for granted, but we did split that number into three sections there. We say 142. And so when we think about numbers, they're broken into those columns, right? Maybe in school you learned it as the ones column and the tens column. And we could rewrite 142 as an addition problem where we have 2 times 1 plus 4 times 10 plus 1 times 100. Basically what's going on there is it's times 1 because that 1 is the ones column. It's times 4 because that 4 is in the tens column, and it's times 1 because that 1 is in the hundreds column. So when you add them all up together, you get 142. And so when we go into binary numbers or hexadecimal numbers, what we're realizing is that this ones column, the tens column, and the hundreds column actually corresponds to powers. Okay, so this is an exponent symbol I have here represented by the caret. And what I'm showing here is that you can represent each one of these rows with basically a multiplication problem, but instead of the 1, you're replacing it with 10 to the 0, or 10 to the 1, or 10 to the 2. So the idea with converting numbers here is basically instead of writing it as the ones column, we call it the 10 to the 0th column. And instead of the tens column, it's the 10 to the 1 column, to the power of 1. So we've just converted the right-hand side of this product here to be the power or exponent form, let's say. Now, the reason why there's a 10 here is because this is a decimal number. The literal only difference if this was in binary is that the 10 would be a 2. That's it. And if it was hexadecimal, the 10 would be a 16. And then that's how you'd get your final number, which in this case is 142. So let's walk through a few examples just to show you how that works. I've got a number here in binary called 101. It's not 101. We don't know what it is. It's a big question mark. All we know is that in binary, it's 101. So it could be, we don't know. We don't know what that represents. But what we do know is that the 1, 0, and 1 fall into the 2 to the 0, the 2 to the 1, and the 2 to the 2 columns. So basically, instead of tens, those are 2s. And so if we just solve this math problem, we'll know exactly what 101 represents. We're converting it from the binary to the decimal. So here it is again. I've taken the 101. I've written it in the form where we have 2 to the 0, 2 to the 1, 2 to the 2. I've simplified the right-hand side here, so we just have 1, 2, and 4. And then when we add these all up, right, 1 times 1 is 1, plus 1 times 4 is 4, so 1 plus 4 is 5. So 101 in binary means 5 in decimal. And just for fun, let's take a more complicated example here. 1010101. We're just going to do the same exact thing. So you're going to write it vertically like this, where you take this number and you put it up at the top. That's our 2 to the 0 column because it's all the way on the right. Then the second to the right is our 2 to the 1 column, so I put a 0 here. Then we have a 1 on the third to the right column, which is our 2 to the 2 column. Right back in decimal world, we would have called this the hundreds column, but here it's 2 to the 2. And then just like that, we go all the way down. So if we wanted to figure out what this crazy number is, 101 or 101 in binary, if we want to convert it to decimal, all you have to do is solve this addition problem. So I converted the right-hand side, make it a little simpler to read. Obviously, these zeros are just going to cancel out. 0 times anything is just 0. And the result is 85. So that's how you compute it. Pretty cool, huh? So now let's go from decimal to binary. So when I think about a binary number, it's essentially just different slots, right? Different columns, ones, tens, hundreds. But this time they represent 2 to the 0, 2 to the 1, 2 to the 10. Just like a decimal represents 10 to the 0, 10 to the 1, 10 to the 2. So when we're converting a decimal to binary, we just need to figure out how we're going to fill in these columns. And we're going to do it in the order of left to right. So the first thing that I want to do is replace the bottom numbers here with something that's a little easier to read. So I've just replaced all these exponents with what the number they actually represent. So for example, 2 to the 5 right here is 32, so I just wrote 32 instead. And now the number we're going to be converting is 504. So what you do here is you work from the left to the right, and you see if it fills in. You see if you have enough remaining in order to fill in that column. So for this first example, we're looking at the 256 column, and we need to know whether or not 504 is bigger than 256. Okay, it is. So what we do is we fill in that column, which means we've represented 256 already, but that leaves 504 minus 256, 248 remaining. So if we just have this number here, 1 with all these zeros after it, that represents 256. So we've got some of our number represented here, but we're missing a part of it, okay? We're missing 248, and so we just need to add that in. Just like if we had the number 104, if you got 100, you haven't represented that last 4 until you put a 4 in the ones column. So basically, we just need to fill in the 248 now. And to do that, we just keep going. So you go to the next column here, 128, and you say, is 248 bigger than 128? And the answer is yes. So we fill it in, and now we figure out how much we've got left. So 504 minus the 256 minus the 128 leaves us with 120 left. So now we go to the 64 column and we say, do we have enough to fill in 64? And the answer is yes, we do. Okay, so now we do 504 minus 256 minus 128 minus 64. We have 56 left. And now we're on the 32 column. So now we say, does 56 have enough to fill in the 32 column? And the answer is yes, it does. Okay, so this is a big number. I should have chosen an easier example. But basically, we go all the way down until we get to 0. So if you fill in 1, 1, 1, 1, 1, you just keep going like that. You get 504 minus 256 minus 124 minus 64 minus 32 minus 16 minus 8 equals 0. And once you get 0, you're done. These numbers here are important. You got to include them too. But you just take you don't need any numbers if you have some zeros left over on the left. You don't need those. But you can add them all together right here. And then that's our answer. 504 in binary is 111111000. Awesome. So that's how you do that. And just for a little quick example here, I did 505. So with 505, let's imagine I didn't fill this in yet. I don't want to give away the answer. Okay, pretend you didn't see that. so you'd be at this stage, right? So you'd have filled in everything here. You've went to the 8s column. You just filled in the 8s column, and now you've got 1 left. So you go to the 4 column and you say, do we have enough for 4? No. So you go to the 2 column. Do we have enough for 2? No. You go to the 1s column. Do we have enough for 1? Yes, we have exactly enough for 1. So you fill that in, 1. You subtract the 1 you just added here, and now you've got 0. Okay, and that's basically what happens. To get zeros in the middle is because we didn't have enough for these columns, but maybe we did have enough for these columns. And so that's what 505 looks like. Whereas 504 looks like this, right? You could tell the difference. It's just a different 1 in the 1s column. Other than that, they're exactly the same. Kind of like how 101 and 100 in decimal are kind of exactly the same. There's just a difference in the 1s column. That's the same exact thing here, right? 100, 101 kind of thing. Okay, so that's how you do it. That's how you convert from binary to decimal, from decimal to binary. If you have questions or if I did a shitty job explaining, let me know. I'll do it again. And if you have similar questions like this, let me know, because I'd be happy to do more videos like this to help you out. All right, thanks for watching.